All right, so remember how it works, right? So we're going to open Anaconda first. I'm going to hit on all apps and then Anaconda. And I usually like to start this way. So Anaconda prompt. I think I needed to be sharing this and I forgot to. All right, so share. Okay, I'm sharing it. All right, so we've opened Anaconda here. So then what are the steps? We need to look for our folder. So I strongly recommend that you do that. So I'm just going to CD into the desktop. EIR. And then I have ITS 520 full, and you guys are section 2. So I'm going to CD into ITS 520 and then section 2. Okay. All right. So I'm there. And what do I have in here? I have just the week 1 demo. So today we're going to write or work on 2 scripts, basically. The Torch basics, just doing some tensor operations. And then after that, build a calculator. The third script will probably be reading files. We'll start reading in files. But for today, I'm going to hard code the data into the Jupyter. So I'm not going to read from a file to avoid that complexity. Okay. So now that I'm here, what's the next step? I need to activate the environment, correct? So conda environment list, yeah. Okay. And now I'm just going to, I wanted to see the environment, so now I can just activate. So conda activate I-37 ITS 520. And then this is just 2. Okay, so I'm in my environment. If you remember, I had already installed everything. If you're using the desktops, you may have to create the environment again. All right, if you use your own laptop, it should be or external hard drive. All right, so it's there. So now what's the next step? Jupyter, right? Jupyter Notebook, very good. So just do Jupyter Notebook. There we go. All right, so I'm going to create my Jupyter Notebook now. So remember, you can click New, Python 3. Okay, I'm going to add cells. I'm going to rename this. And I'm just going to say Torch tensors, just some descriptive name. Hit rename. All right, and we're all set. So now we're going to add the library. So those were already installed. So I'm going to do import Torch and import Numpy as MP. Okay, I'm going to hit run, remember, and those are really the only libraries that I will need for this example, I think, just so that I can create some tensors. All right, so we won't spend too much time on this. They are similar to the NumPy examples in general, and that's kind of what I want to show you. Okay, so we're going to do the first one, which will be creating a tensor of all ones of size 3. All right, so we'll start with that. So hit finish for me. Now, this is an important notion or thing to be aware of. When we are building a deep neural network with Torch, right, everything that goes into building that needs to be Torch. You can't take something in NumPy and attach it to the what is called a computational graph. So you always, even if you have data in NumPy, etc., you have to convert it to a Torch tensor and then attach it. Otherwise, it won't work. Okay, so remember that. So basically, always, if you're using Torch, convert everything to Torch. Okay, that's kind of the best practice. So let's go ahead and create a variable over here, A. Remember, we invoke Torch. dot ones. And we're just going to specify that we want it to be of size 3. Okay, and then once we've created it, we can just go ahead and print. Okay. See that? It's that simple. So now go ahead and you can see we've got our tensor 1, 1, 1. Notice it's different from NumPy, where NumPy had no commas. Here, the torch tensor does have commas. It's just, how they built it. Okay. If we want to change a value, let's take the last value. So we're going to do here A, and I want to change the last value, which is 2, right? And I'm going to change it to, let's say, 17. Okay. So now I'm going to print A again, and let's take a look. And you can see now I have 1, 1, 17. So it works pretty much the same way as NumPy, except remember that they're not actually the same like data structure in memory. Okay. All right, let's do another one. So now let's take create 10, let's start with a list in Python. So this is going to be 4.0, comma 1.0. I am recording, right? Okay, 1.0, comma 5.0, comma 3.0, comma 2.0, comma 1.0. Okay, so this is a Python list, and now I'm going to convert it into a torch tensor. So we're going to go ahead and do that. Now, as a convention, a lot of people do this, and I actually like this practice. You put something like this, so B_T, where the T now indicates torch. And that way you just know, okay, this is in this format or that format, and that's useful. Right? And so now I'm going to go ahead and do torch dot tensor, right, of B. So run B in here. And now when you print this one out, B_T, it should be a torch tensor. And it's ready to be processed. Okay. Any questions? Yeah, Lenny.
So all that does is it converts it into a tensor memory?
It converts it into a torch tensor.
Torch tensor.
Yeah. So when you're using torch things, you need to convert your arrays, your data into torch tensors. Okay. You can't go, because it's usually going to start as a NumPy. It's going to start as a text file that gets read with pandas, maybe into a NumPy array, and then you go to a torch tensor. Okay. Let's do another one. So let's create another variable C. Remember, these are currently lists in Python. So we're going to do the first one, 4.0, comma 1.0. Okay. And then this is a list of lists, right? Then we have 5.0, oops, square bracket here, comma 3.0, square bracket, comma 2.0, oops, keep forgetting the square bracket, comma 1.0, square bracket. All right, so now we want to take this list and convert it into a torch tensor. So that's going to be C_T, and once again, we invoke torch dot tensor C. So now if we print C_T, that will look like a torch tensor, and you have it right there. Okay. Now, so we know how to convert. The next thing that is very useful is to always look at the shapes of things, right? So in this case, I'm going to print the shape of the tensor. So I'm going to say print and you take C underscore T dot shape, and that's gonna give us the dimensions of this matrix basically. So it is 3 by 2, so that means it has 3 rows and 2 columns. Other things we can do, we can create, let's say, a torch of zeros. So let's do another example. D, and this is going to be a torch tensor, so we can do D underscore T torch dot zeros, okay, of size 3, 2. So this should give us a 3 by 2 matrix of all zeros. So if we print D underscore T, you can see we've got all zeros over there, right? So we did several examples of this with Numpy, where we are creating zeros, ones, random, and random with a normal distribution. Now that I have this, let's go ahead, and you played with these concepts of indexing and slicing, right? So though, especially slicing needs to be something that you're very good at, okay? So let's now take a look. I'm going to add some values to this matrix. I'm going to add 17 and 14. So that's indexing first, right? So I'm going to take D underscore T, and I want to add the value 17 to the second column of the first row. So how do I do that in terms of indexing? What are the index values here? 1, 2.
Yeah, 0, 1, 2. So
I want to add 14 to the second column in the first row.
Oh, I thought you said my bad. So 0, 2. I thought you put 1 down.
0,
Yeah.
1. Right? Remember, it starts at 0, right?
Oh, that way too. Right.
Yes, that way too. Okay. So then let's do the same, but for the second column of the second row, and let's add 14 to it. So this should be 14. So how do you index it? What do you guys think? What's the index? You should know this. This was in your Numpy examples, right? Very, very, very important.
Sorry, what was the question again?
So the question is, I want to add 14 to the second column of the second row.
Second column. 1 and
1, 1. All right. So if that worked, we can print it out. Let's see what happens. Did it work? Yes, right? That's what we wanted to do. So that is indexing. Now let's do, I want you to slice. Okay, so we're going to do some slicing. And I want you to give me, what do I want? I want the second row. Just slice out the second row here. How do you do that? So from DT, second row, all the values in the second row, slice it. 1, that's it. Doesn't give me the second row. 1, 2. Is that what you said?
Yeah.
Okay, let's try it. Nope. Oh, wait, actually. Oh, yeah. Well, yeah. Is there another way of doing it? Yeah. Just 1. I like that. I like that. Another way of doing it should be 1, right? Same thing. All right, a little bit more precise. Yeah, please go ahead. You want me to make this bigger?
Like a little, like it's-
I can see, if you can remind me, yeah, I can do this.
thank you.
And then, yeah. Good, yeah. Does this make sense, guys? All right, a lot of tricks, right? A lot of tricks. What else can we do? Now, there's something called, this is a concept that you should be familiar with. It's a complicated one, okay? But it's one that you should be familiar with, which is adding dimensions. Sometimes this is referred to as squeezing, on squeezing, that kind of thing. All right, and it's the idea that you add a dimension, right? So you make a matrix into a three-dimensional matrix. So from 2D to 3D and so on, right? So there's several ways of doing this, and there are specific situations where you're going to need this, like when you're making multiplications of one tensor by another tensor. This is going to happen a lot, and so we will need to do these tricks. So I'll show you guys. So let's say I'm going to take the shape. So the way to understand this is to print out the shape first of dt, right? So I'm going to need to make it smaller. So you can see the shape is 3 by 2, right? And that's a two-dimensional thing, but I want to add a third dimension because I have, we read everything into a GPU in batches. So what that means is that I'm not just going to always give it one sample where it might be 3 by 2, but I'm going to give it 8 samples of 3 by 2, right? So how would we do something like that? So then that means this needs to be a cube, right? 3 by 2, but there's 8 of those 3 by 2s. Okay, so let's just think about how we could change the dimension here. So I'm going to say dt unsqueeze example, let's say. Okay. And I'm going to take d underscore t square brackets, and then I'm going to do two tricks here. One is when I do these, oops, not that. When I do these 3 dots, right, it basically means I'm creating this new dimension, everything else, figure it out. That's kind of what you're saying. So here I'm going to add a dimension called none, and that's just adding one more dimension. You don't specify how many values you want there. And then this should give us a new dimension in our model. So if I click run, oops, sorry. There. Oh, and I forgot to print it. So let's do dot shape. And you can see now I have 3, 2, 1. So I've effectively added this dimension. Let's say that you're doing operations with cubes, right? And so now you would need to be this in 3 dimensions. Another thing you can do is move this to the other side. So I'm going to do Control X, comma, V, get rid of that comma there. And you can see I've added the 1 dimension in front. So it's now 1, 3, 2. So right now, just understand that we can do this and get this to happen. Later on, as we start building machine learning algorithms and we start to consider things like batches, etc., you will see that we will have to do these operations. And this is just like a math thing, so that things align a little bit better. Okay? All right, so this is one of the complex operations that we have to do every now and then. Let's create now another tensor. This will have 4 dimensions, okay? So let's create another one. Why? Because now we're going to assume that we have images and they are in color, and we are going to feed into our deep learning algorithms batches of a certain size, okay? So how do we do that? So let's create a variable called batch underscore t. Again, remember the t just means tensor, or yeah, PyTorch tensor. And I'm going to do torch dot rand n. So remember, this is just basically random values. And now I'm going to specify here the dimensions. So for instance, I'm going to say 2, 3, 5, 5. So what do these represent? Well, they represent, the first one is batch size. So batch size means how many examples do we feed at a time? Okay, got it? So we can have a data set of 1 million, right? But you're not going to feed 1 million images into the machine learning algorithm all at once. Why would you not want to do that? RAM, right? Memory. So we have, this is the reason. Nothing else. If we could feed all the data at once, it'd be wonderful. But we just can't, right? So we're going to run out of memory. So what you do is you feed the data what is called batches. So we give 8. The second one is for the 3 grids that we have. Remember that color images means that we're going to have an R version, a G version, and a B version, right? So then we can say 3. So this is referred to as channels for RGB. That's what that means, right? And then after that is the size of the grid. So in something like the data set, not MNIST, but the other one that's in color, it's a fashion data set. The images there are 32 by 32. So this is a perfect example of that. Oh, well, 32 by 32. I should have said that here. So that's going to be the rows and the columns. And that would be 32 by 32. The problem with this is it's too big, right? So if I try to print this one, it's difficult to interpret the information. So you can see here, that's the data there, random values, but it's difficult to make anything out. It's better just to print the shape sometimes. You can check this to make sure that there's data in there, right? But this gives us what we want as well. You guys understand? Why is this stuff important? Because, as I said, with images, we got images that are 32 by 32, but they're in color. So there's 3 of those. And then you don't just feed one example at a time, you feed several examples at a time. How many examples am I feeding here, assuming? 2. And the batches aren't that big, okay? So batches are usually 8 to 16, etc. Otherwise, the models really can't handle more than that, especially like our models, with 1 GP. Obviously, the more computing power you have, the bigger the batches could be. But there's even literature about that, like how big should they actually be and everything. So in general, I think 8 to 16 is good. All right, any questions on these? As I said, these are just simple exercises to kind of practice and develop that muscle memory. And then all of these things you will see me do as we progress in the semester. We'll have to do these little tricks and they'll get more complex. But this is why they will pay you the big bucks, right? To be able to do this. All right, so let's do another one, torch ones, and let's do it of a data type. So I'm gonna do double points, let's say. So double underscore points. It's just some name. Torch dot ones, and it's gonna be of size 10, 2, and then we can specify a data type here. So the data type will be torch dot double. And there's a lot. So with a lot of these things, you can't memorize any of this, right? You will always have to like Google it, the data type and everything. Go to the descriptions. So we can go ahead and print this out. Okay, so I'm going to run this one, and you can see that's what it looks like, and it's already giving us the data type there, torch.float64. If you notice, that's not something that Numpy gives you. You can also get that by just running .dtype, so that should give you the data type. Okay, these are important things. You will see when we start doing regression problems, etc., that I will intentionally change the data type to something like float 32. Okay, sometimes you get strange errors with this kind of thing, so just be aware of them. Okay, the data type is important in Torch. Any questions so far, guys? All right, we just have a couple more things, and then we'll take a 10-minute break, and then we'll start our Celsius to Fahrenheit calculator, as I was saying. So let's see what else we can do. Oh, one thing that's important is NumPy interoperability. And what that means is that sometimes you have to like really quickly go from a Torch tensor to a NumPy array. When does this happen? This happens when you're done with the model. Let's say you've done some analysis and you did your predictions, etc. Now you need to quantify performance. You're going to find that it's a lot easier just to use like sklearn at that point, right? sklearn is a library, and maybe you want to use sklearn for the performance metrics. But sklearn only likes to work with NumPy for some reason in that example. So what do? You will go from Torch to NumPy. Okay, so that's what we're going to talk about now, and that's usually called interoperability. Believe it or not, first of all, the first one of these frameworks came out in 2015 in December. So that's only been like 8 years. Let's start there. And then Torch came like a year or two later. And really like 2-3 years ago, this wasn't even possible. All right, so this has been changing a lot, and they get easier and easier, certainly. But this was painful to do before. All right, so how do you go from Torch to NumPy? So we can do, it's very easy now. That's certainly the truth. So I can do torch dot ones. Okay, and let's say I do something that's 3, 4, right? So all that matters is that we want to convert it from Torch to NumPy, right? So I run it. I have my Torch tensor now called points, right? So if I run this one, you can see it's a Torch tensor. Probably a good time to save. Okay, so now I'm going to take points and convert it into a NumPy array. So, you know, we can use the same convention, which is to add underscore and NP. That just reminds you, oh, this is a NumPy array. Okay, that's, you know. What? And then you can do points dot NumPy underscore like that. And now when you print this one, you will see that it is now a NumPy array. It says array instead of tensor, gives you the data type. Do you guys understand? Now, what if you have a NumPy array and you want to make it into a Torch tensor? That's also pretty easy to do. We're just going to repeat this exercise going back. So let's do points underscore t. So notice that now I'm giving it the t convention, and I'm going to say torch dot from NumPy. You see how easy that is? So we just basically invoke this function. This will expect a NumPy array in here. So you can say points underscore NP, and it just converts. Okay. So then we print this one. And notice it is now a tensor again. So this is a quick way of knowing if it says array, it's NumPy. If it says tensor, it's a Torch tensor. All right, very good. So yeah, so that completes the exercises that I wanted to do. Just kind of play a little bit with tensors. There's way more, of course. The rest, that's why I gave you those 50 or so NumPy problems. Go through those and just be aware that there will be equivalents of those in Torch. Okay, got it? All right, so it is 6:10, so it's a good stopping point. So I'm going to pause the video here.